Hello, everybody. This is the Neapolitan room. We're going to be seeing JavaSnoop, how to hack anything written in Java. And I'm going to introduce your introducer, Sami Kamkar.
Thank you. It's my absolute pleasure to introduce the man who needs an introducer to introduce the name. My previously foe, now my friend, Arshan Dabirsiaghi on JavaSnoop.
Thank you very much. I wanted something, can you hear me? I wanted an introduction that would be more awkward than my talk, so that's why we did that. So this will go smoothly compared to that. So we're releasing a tool today. Actually, we released it a few days ago called JavaSnoop. The whole point of JavaSnoop is to make theoretical vulnerabilities turn into actual vulnerabilities. So if you're looking at this diagram here, sorry, I'm Arshan Dabirsiaghi. I work for Aspect Security, Director of Research. There you go. Let's talk about JavaSnoop. So here's a dumbed down version of any architecture diagram of any application you've seen ever, right? So a typical three-tiered thing. So the client is labeled client, and theoretically any more information about the client is irrelevant because you know that the client controls their own machine, therefore they can have their client do anything. But actually, in practice, that's a lot more difficult, and especially if you're a consultant or you ever do time-boxed engagements, if you're basically working for real in the security world, you don't have a lot of time to turn the theoretical into the practical, and theoretical vulns don't really get fixed at the same rate that demonstrated vulns do. So, client is a client. So we're going to talk about why hacking Java applications, because Java's just an example here, right? So Silverlight, .NET, Flash, whatever, all these are perfectly good, thick client-side technologies that don't have great tools for, turning those turning those theoretical vulnerabilities into real vulnerabilities. So I did it with Java, but I really want somebody to make one in Flash so I can, win all those Facebook games. But that was a lot harder than doing it in Java. So let's talk about why it's actually difficult, because, in practice or in theory, Java is a very malleable language. It's supposed to be deterministic to compile and decompile. All of the data objects are well known, the structure, there's a spec out there. So everything kind of seems clean from outside, but really it's not so clean. So we're going to go through a week in the life of a security consultant where they have an engagement where they have to review a thick Java client. And this is really kind of where JavaSnoop came from. So, start the 24 theme music. So security company X, could be any security company. We want you to test this important applet. Right? So an applet is, can be thought of the same way as a Java desktop app or a Java web start application. It's all just Java, right? And so people are very aggressive in the consulting world about getting your business. So they'll bid on a job without really knowing how to do the job. So of course you can't, you can't learn the Java framework in 1 week. And also you can't use any tools on thick Java applications. So you can't scan them, you can't whatever them. So it's all about digging. So here's our applet, our target applet. And again, we got 40 hours to do it. We have zero intel on the applet. Looks like some kind of chat thing. We probably have no idea what the traffic looks like. That's not going to be too hard to find out what it looks like. But initially we have no documentation. And one of the things you learn after being a security consultant for a while is the documentation often is totally wrong or leads you down very wrong paths. So after bitching about not having that useful intel, you're already behind the 8 ball. So the way I see it, you have 3 options for trying to hack a thick client. The first option is what everybody immediately goes for, and that's to hack the traffic between the client and the server. You see, we have these great tools for proxying browser traffic, right? We have WebScarab and Fiddler, Burp, and all these tools that have been pretty much commoditized. We commoditized that problem. But when we have a thick Java application, it's not always that clean, right? It may not be, they may not have HTTP at all. And even if they do, they may not have configurable proxy settings. So even if it does use HTTP, you can't get yourself into the middle of it without doing some crazy stuff. And on top of that, the traffic might be obfuscated in some way that, although it's theoretically possible for you to alter, in practice it isn't. So for instance, if they're using serialized encryption or serialized objects, it's possible that you could write a tool, like somebody wrote a burp plugin that would allow you to edit a serialized object across the wire. But in general, it's kind of hard. So if they use encryption, like their own kind of encryption, on top of that, it's going to be hard to proxy and alter that traffic in a way that would be useful. And if they use custom protocols. So if they have a custom protocol and you only have 40 hours to review it, by the time you're done reversing the protocol to figure out how to actually make meaningful tests, you're going to be out of time. So we can't let it get that far. So this option just doesn't work on its own. So for this particular applet that I'm looking at, I Wiresharked the traffic. Looked like it was going over HTTP, which was great. But then I discovered it wasn't actually HTTP. It was some goddamn weird new Bizarro protocol they invented. So again, more time just down the drain. So this is the second option. This is what Stephen DeRise, I think, just talked about in the other talk. I didn't get to see it, but he probably told you something like this. There's this idea that you can grab the classes, grab the code base of the applet or the desktop application, whatever, decompile it, then alter it to be malicious, and then recompile it and run it. This is a good idea in theory. All right, these are our theoretical next steps. But what happens in reality? Code doesn't even compile. Your tests are either completely invalid because just the integrity of the application is shot because the decompilation process is not deterministic, or they're just never happened because it was too complex to actually recompile. So that's our option number 2. Our option number 1, hack the traffic. Option number 2, hack the client. So here's what happens when I tried option number 2. Just grab the applet code base, and again, it's a binary, right? It's just a jar file you download, so it's a compiled binary. All references should be resolved and all that kind of stuff, but actually when you decompile it, I ended up with 3,800 errors. So we don't have the kind of time to fix 3,800 compilation errors before, and insert error malicious attacks and expect to get meaningful tests in 1 week. And time just keeps ticking. So option number 3, the limitations are similar to option number 1. The protocol might not be something you're familiar with. It might be expecting serialized objects or some new protocol that you don't understand. So the idea that you can go directly to the server, bypass the client entirely, in some cases this might work. In fact, in some cases all of these might work. But I'm saying in the majority of them they won't. And it takes too long anyway, to be realistic. So again, the serialized object, the encryption, and custom protocols, all that stuff just makes that really, really difficult to do practically. So we tried to talk to the server. Again, it was some new raw byte protocol that I'd never seen before. The applet was written, probably 5 years ago. So something I just didn't understand at all. And I wasn't going to, try to understand it because it wasn't going to do any good. By the time I was done understanding it, the time box was going to be closed. So in my life, whenever I have a serious problem, I always look to Anna Faris for inspiration. Anna Faris, a Baltimore native like me, she's my muse. So I said, what would Anna Faris do? And she said, well, what if you had burp, or web scarab, but used it to intercept method calls within the JVM? So what if you could set up a breakpoint in the Java process, essentially, where, and not like Ali debug level interception. I'm talking about, something like all of us can understand. So something where when that method gets hit, you could alter the parameters, or maybe you could alter the return value on the way out. That kind of thing would be useful to us, because then if we're inside the JVM, we can set a breakpoint somewhere where we understand what's happening before maybe our data gets onto the network. Right? So I can edit a person object if I have the right interface, but the serialized object, version that's going across the wire, I really don't understand what's happening there. So Anna is surprisingly technical on top of all her other admirable traits. So this idea that we could intercept method calls sounds a lot like instrumentation to me. So instrumentation has been something that's been used a lot in the lower levels of security, reverse engineering and all kinds of cool stuff. But we haven't seen much instrumentation at the application layer. So that has to change, because instrumentation is just too powerful. I say instrumentation is like having a rich white uncle. It opens a lot of doors. So you still got to step through those doors. You still got to go to the job interview, right? But they get you places. So what is instrumentation if you're not familiar? Instrumentation is all about wedging new code into a binary. Right? That could be a binary after it's been compiled but before it's been run, or after it's running. You could change it at runtime. So this is an example of using instrumentation to put in a couple logging calls in the do something method. So this is a silly little method, just does a hash, and it returns the result. So that's it at a high level, but to actually do it, you need to get a little bit lower in the stack. So what will we do with instrumentation? Maybe we should answer that question first. So here's what I'm going to do with instrumentation. I'm going to wedge in a call at the beginning of the method that makes a synchronized call out of the current process and into my process and gives me an opportunity to edit that data. And then I'll do the same thing with the return value. Okay, so all we have to do is pick a method, wedge these pieces of code in there, and then watch for those calls in our other evil process. So at the end of the day, what I want is this. I want some evil program like you see on the right, JavaSnoop, and then we've got our applet on the left that we're attacking. So when our method gets hit, the method that we're interested in, it'll send the parameters over to the other application, to the evil application. We'll edit them there, and then we'll send back the tampered result. Okay, so the good data is in the original application, sends it to the evil JavaSnoop program. JavaSnoop sends back tampered results, and the applet is never the wiser. All right, so same thing for the return value. All right, so instrumentation is not an easy subject, and it took a lot to understand what was happening, to understand how to use it, and to do what I wanted to do. But it took a lot of time, right? And time is like the one thing we really don't have in a typical assessment. So to actually redefine a class in Java to put in our calls, we need to actually work with the bytecode. Right? I tried putting in alert document.cookie, that didn't do anything. Turns out that's not valid Java bytecode. So clearly we needed to work a little bit harder. So there's a tool by Sami Koivu, I'm probably butchering her name, sorry. It's called reJava, and it shows you bytecode of existing class files. So here's an example of a method that I used reJava to wedge in the bytecode for a simple system out print line. So I just put in some print statements at the beginning and end of a function. So writing position independent bytecode in Java is actually ridiculously easy. It sounds like something that might be hard, but it's really, really easy. So with that, having that knowledge, it wasn't too difficult then to turn those system out print line calls into synchronized callouts. So if you're a Linux person and you're a typical daily Dave reader, may not know a lot about what's happening in the JVM. So I made a little analogy here, okay? It's an analogy. It's not exact, so shut up. So ring 0, in ring 0 we have the core Java classes like Java LangString, Java Socket, and all these other classes. And so those are all trusted, and they can all do whatever they want. There's no security restrictions on them. But we have extensions. So if you look into your Java program files, Java extensions folder, you'll see things like QuickTime have privileged jar files in there, kind of scary. So there's lots of people that have privileged extensions. And again, those extensions can do whatever they want, no restrictions. But then there's also your code, which runs in userland, which typically doesn't have many permissions. Now, what's interesting is in Java, to instrument classes, you have to use an agent to do it. So an agent is an evil little, Drew Rosenhaus, an evil little, sports agent, right? Think Jerry Maguire, that you drop into another process. And that guy, from that point forward, he acts on your behalf. So you have to write your agent in such a way that you can communicate with him, from outside. So once we drop our little Java agent in, not only does he have access to the classes in userland, which are your custom classes, but he also has access to classes like the Java classes, the trusted ones. So even if the code is signed, right, even if there's all kinds of Java security around, in the framework, you got your policy files and all that stuff, JavaSnoop will turn that off, essentially, and be able to use these use this agent to work with those classes. So we have access to all the classes. So those are the two big parts of JavaSnoop, is the agent, the evil agent that does the instrumentation, and then there's the GUI that talks to it. So even after learning about all this cool stuff and writing this program, we only have 12 hours left. Thursday is when you start sweating. So there's never enough time, but wish you had more. So let's talk about how JavaSnoop could solve the problem of testing this applet. Okay, we're going to go through just very simply the life cycle of a typical JavaSnoop test. Okay, so starting up JavaSnoop is really easy. You just double click on a batch file or a bash file. So what that bash file does is it turns off Java security completely. Okay, turns it off completely. Turns it off completely. So if you turn on JavaSnoop and then browse to, Samo Kovu's website, you're going to get owned because there's no security anymore. And there are so many people with Java Ode right now that their exploits don't even have to work if you're going there with JavaSnoop on, right? Because you're just going to get owned because there's no security. So no security. So we started up JavaSnoop first, and then we started up our target program. This is an applet running inside a web browser. I haven't had to decompile anything. I haven't had to look at any protocols. I've had to do zero work. This is so easy a caveman can do it because a caveman wrote it. So the third step is to go into JavaSnoop and just pick any process. So I'm going to choose the process that the applet's running in, and I'm going to drop my agent into there. All that's invisible to you. You just double click on a process. Okay, how do I know which process to pick? Well, we give you a bunch of information about each process, so it'll help you figure out which one is yours. But you'll be able to brute force this pretty easily. And applets, by the way, always have the same name, no matter what browser they're executing from. So the next thing to do is to pick a method, right? So there's going to be some manual work here, right? We can't, JavaSnoop can't figure out what's an important method in your application. So let's just search for one. So we can see here a little screenshot of me searching for the word send in method names. So I have a bunch of results here, so I just picked the second one. So on the bottom, I have another piece of the GUI highlighted here that asks you what you want to do with that function. So we have lots of options here. We can print the parameters to the console or to a file. We can run some custom Java. Okay, so you can just write in whatever Java you want and just have it executed when that function calls. You can tamper with the parameters. It doesn't have a return value, so we can't tamper with that. or you can pause the program if you have like a time of check, time of use vulnerability that you want to open up the window to, you can pause the program. So we're going to do something simple. We're just going to tamper with the parameters to this send function. It looks like it takes a byte array. So once we choose that function, the JavaSnoop GUI tells the agent that's inside the process that was automatically inserted, it says, hey, I want to intercept this method, and when that method is hit, send me the parameters and give me the opportunity to tamper with it. All right, so again, I'm going to draw an analogy to the web. This is just like Fiddler or Burp or WebScare. Whenever you have intercept turned on, whenever that function gets called, you get a little pop-up box that says, how do you want to mess with this data? So we do the same thing. So when that method gets called, you get a little pop-up. Gives you some information. It says, here's the class that's calling. Here's the method that's calling. This is something you wanted to edit. So here's your opportunity to edit it. So if you click on this nice little edit button, you'll get a screen that's it's nice for editing byte arrays. We have lots of different views, right? The view for editing a byte array is not going to be very useful for the view if you want to edit a Java list or a hash map or anything crazy like that. So we have all different kinds of views for all different types of objects, including custom Java objects, right? So even if you have classes in your app that aren't serializable, I can still serialize them, and deserialize them, all that kind of stuff through some IBM library magic. So here's an example, here's the byte array that I just intercepted. And clearly you can see it's not HTTP, it's some weirdo byte protocol. So I see one of those bytes has my user ID in it. So, and this is a chat message. Okay, so I'm sending some bytes to the server, and I'm providing my user ID to it. So this is a classic pattern of you can't trust the user, but the user is providing their own user ID. They're saying, I am this person. So I'm going to change that message. I'm going to change that byte so that it's the byte of my adversary. Alice is her name. So that worked. The chat message appeared as if it came from Alice, and we feel like we earned our money for the week because we found one serious flaw. So the next time a Java thick client comes around, I'm going to have this tool already built, and I'm going to be a lot faster. And that's what happened to get us here today. We had to build a very rough prototype of this tool in, I think we actually had 2 weeks for a client that was pretty much doing the exact same thing, except it was all financial stuff. So that's how we got here. So I want to show you guys the tool and do some stuff. If the demo gods fail me, I will have some videos with some Fall Out Boy background. But let me tell you this first. There's still an open question here of how do I choose which method to hook, right? And by hook, I mean like which method do you want to intercept, basically. So the first answer to that is, well, maybe you can search for the method by name, right? You don't know what the method name is, but send is a pretty good idea. You have a pretty good idea what send is going to do. It's probably going to send something to the server. You can also search by return type, or if you just want to browse through the classes. For most applets, it's pretty easy to just walk through their classes and walk through their methods and just go through that. Probably take a couple hours. But you'll have a good idea of their namespace and what different classes are doing. So the second way of finding out which methods you want to hook is my favorite part of this talk. So absolutely pay attention. Put down Twitter for like 1 second. So we wrote this thing called canary mode. So the idea is that you don't know, let's say you have a form in your Java application that you want to see how that data travels from that GUI to the server. So the idea is that let's put a canary value into that box, and then let's watch as that piece of data flows through the system. So to start canary mode, you go to the menu, start canary mode, and then you put your value into this box. This is going to be your unique value that should not be seen in any other part of the application. Right? So it's something unique to this very test you're about to perform. So you put in something unique there, and then you hit Start Canary Mode. So that disables all the other stuff you had going on with JavaSnoop, and it enters this new mode. So now it'll look at every single method in the JVM, Java methods, userland methods, whatever. And if a single parameter to that method takes a string in our example, then it'll insert a little listener into that method. And that listener, if that listener detects that unique string that you put into the box, it'll send a little canary chirp back to JavaSnoop. So I'll let that sink in for a minute. What's going to happen then at the end of the day is you're going to get all this data back about which methods your data went through. So we really created a very dirty, hacky way of doing data flow analysis through the application. So this slows things down a bit because we're instrumenting basically every method in the JVM. But the results on the screen show you what happens after your canary's been floating through the classes. So the first place our function went, or our data went, was is trimmed empty, right? And at the end, it went to VW self public, whatever that method is. But what you found is all the methods that touch your data, right? And the last method in that list is probably the last place you have a chance to edit it before it goes off to the server. Okay? Okay. So answer number 3, how would you know which methods to hook? Well, there's still always the hard ways of doing stuff. So you could decompile the code into an IDE, and you could look through it. Maybe you could get some kind of static analysis tool to help you find something you might be interested in. I'm not 100% they're going to be any use at all in this particular case, but there's no substitute for just looking through the code. Even if the code doesn't compile, having the decompiled code there to look through is always going to be helpful. So I think I hit on this earlier, but so applets run obviously in a very, 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 very restricted place. Way more restricted than userland. So the agent that we install into the application, it needs to do a lot of different things. It needs to be able to redefine classes. It needs to be able to read private fields with reflection. So it needs to do a lot of different stuff that you're not normally allowed to do. So this is why we turn off Java security. And I'm sorry about that. I wish there was another way to do it. But we have to turn off Java security. It's not like I took a shortcut. So I really can't stress that enough. You cannot browse anywhere else while you're running JavaSnoop. Talked about that. So something, a very important point here. I did a dry run of this talk at an OWASP chapter meeting last week. And the guy was like, well, at the end of the talk, I guess he wasn't listening. He said, I don't understand. You didn't show me any vulnerabilities on the server. You didn't prove that any vulnerabilities on the server. So JavaSnoop doesn't create new vulnerabilities. Okay? It just gives you a easier way to find and exploit the vulnerabilities that were there before, but that you had no idea were there. Okay? Does that make sense? So we're not creating any ODay with this thing. We're just finding and exploiting it. So it was maybe theoretical before, but hopefully now it's practical. I've got this running on XP, Vista 7, Mac now, and Linux. So if you use anything else, I hate you. And I won't support you. Let's do a demo. So here's my favorite radio station, or my favorite radio show, the Junkies in DC. They have a chat room on their site. So I was given very explicit instructions not to do anything malicious here. So what we're going to do is I'm just going to prove to you that this stuff works. And if, in case you're wondering, I did very well in my final world. Oh, you can't see it. Why can't you see it? Oh, I know why. No, I don't see it on mine. Okay, well, I'll try to do it from here and look over. It'll even show up. All right, let's try this. Oh my God, no way. So, this is going well. It's going well so far. Full circle since the introduction. So, this is the chat applet I'm talking about. Again, just a radio station chat applet. You wouldn't presume they would have much security anyway, right? So, here we go. I'm going to, oh, actually I need to open up two of these guys. Can anybody give me a real solution for this? Somebody tell me when I'm on Firefox so I can't see it. Up. Up. Press F. That's a good idea. Am I close with the up? Down. Up. Up again. Two more. All right. Now what? Down? You're all talking at once. I can't hear. Can you see it? Down one. Hit enter. This is, I feel terrible for blind people. So I don't need to do too much in this window. So this guy's just going to sit here. Oh, crap. Anybody live in the DC area and know the junkies? No? Oh, yeah? Good. Good. Okay, so I've configured my Java settings so that anytime a Java process starts up, it'll show me the console. So here's a second user just sitting in the chat room, and I'll show you why we needed that in a minute. That looks like a JavaSnoop. There we go. So this is the JavaSnoop UI. We have videos and screenshots online that will like walk you through the UI and stuff. I don't want to get bogged down in details. I just want to show you what it can do. You guys can look up that stuff later. So I hit attach process, and there's a bunch of different processes here. And there's two applets running. So I'm just going to pick one of them. I don't know which one it is. And here we can see at the top it says it's attaching. So what it's doing there is it's bringing all the classes that are in that target applet and bringing them into its own process for analysis. So now we got the green stuff lets us know that it's working. So I don't know which one I which one I attach to because it's running in two browsers. But I'll just, we'll see when I do this here. So I'm going to hit add new hook. So this is probably going to be your cycle here. So again, you can browse through your classes, or you can just type in classes. So if you type a class into the box, it'll show you all the methods, etc. But I want to search for a function. Okay, I'm going to do what we did in the slides here. I'm going to search for the word send. So I just typed in send and hit enter, and it went through every method in that other JVM, and it brought me back the results. So nothing about this has been hard so far, I hope. Now here will be a tricky part. So one of them says regout.exec. It's this one? One more down. Now I need to find my mouse. That'll be easy. Really? It's at the bottom? Oh, there we go. Double click. Wait. Did I get the wrong one? God. Yeah, shortcut key would be good. Don't get smart. Here? Here? Okay, now it's the second one. Okay, so is that checkbox checked? This is a lot of audience participation. I bet you didn't know it was going to be like that. So I've got this one selected here, and the UI is a little different from what it was in the screenshots, but not a huge deal. So I think print parameters is selected. So I'm going to hit the console button here so that when that method gets called, the parameters will be dumped to the screen here. And I'm going to hit tamper with parameters. Is that this one? This one? Okay, so now that I've made those checkboxes, now all I did was check them, and now, just in the background, automatically, we have traffic. Look at that. So the server sends, there's some kind of heartbeat protocol with this particular application, so we're going to see traffic maybe when we didn't do anything. So I'm just going to say accept changes because I don't know what that traffic is about. So I'm going to go, and you can see what happened here. We got a byte array, right? And we got, I think the console says something about it. You probably got a tamper request that you can, that was logged. So now I'll go back to the chat applet. I don't know if this is the one that we chose to intercept or not. So I'm just going to go and start to type a message. I'm going to hit the letter A, okay? And apparently this is not the one we're looking for because that would have been intercepted. There's Chrome. So now I'm going to type the letter A. Good, nothing happened, right? And here's JavaSnoop. So if we edit that particular screen, we'll see, if you look through the data, you won't find anything too amazing. Again, this is just a heartbeat to tell the server, hey, I'm typing, so that other users see the message that this person's typing. So accept changes, I don't care about that. And it's getting called a couple times. So I'm going to disable the hook for a second. Did I do the wrong one? No, they're both disabled, okay. So I'm going to type in 4 A's, right? Right? 5 is fine. That's fine. And now I'm going to tamper with parameters. Is this one? Oh, it was already checked. I need to go up here, right? Right, but now I want to check it again. Or no, is it unchecked right now?
Yes, it is
unchecked. Okay, so now I'm going to check it again because I do want to tamper with the traffic now. Oh, I did uncheck that. Here? Right here? This is good. Yeah, good. Please don't walk out, please. No, it's going to get better. So now I'm going to hit send. Okay, and I should have got a pop-up, and I did. So I got an opportunity to edit this data before it leaves the server, right? And do you see anything there? Just the heartbeat? Crap, where's the, there it is. Okay, got a heartbeat there. Let's see if this has it. This has the data in it? Okay, now I really can't see what's happening here, so I'm just going to type. Is this one of the letters? Okay, I'm going to change that to, oh, I got to change it over here. God damn it. This is where they are, right? Okay, so I'm going to change that to 42. So now that's a B. So I would normally do a little bit more, but since I'm legally blind now. All right, now I'm going to say accept changes because I like my edits. And so that was sent off to the server. Okay, so what does the user see in this window? This is Chrome, right? So the user sees what they actually typed into the box because the client does prediction of what's going to appear in the box. They don't actually get that chat message back. So that's why we open up Firefox. So if we look up here, does it say, it says B? Okay, all right, that was really well done. Thank you. You guys, clap it up for you. Clap it up for you. Thank you. So we proved now that we could just jump into a process, tamper with the method call, and tamper with the parameters, with the return value. You can print them out for analysis. We can pause the program. Now I'm going to show you something. You can also print out the stack trace, so that might also help. The stack trace of when that method got called in the thread. So I'm also going to show you, this is the coolest part I got to add in the last few weeks. JavaSnoop, nice. So now I'm going to go down to manage JAD. How's that, right here? All right, so is that checked? It is? And it's not? God damn it. No. Get out of my face. I can say accept changes and disable hook, so it stops bothering me. Okay, now I'm going to tell it where JAD lives. Okay, and there I have a path to JAD. If you're not familiar with JAD, JAD is a decompiler. It's like one of the most popular Java decompilers out there. It's been around a long time. So now JavaSnoop knows where JAD lives. So let's tamper with parameters again, and we're going to see something cool happens. So I'm going to enable it. Right, that's enabled now. Now it's unchecked. Okay, so now it's checked again. I'm going to go into Chrome. Am I in Chrome? Okay, and I got a pop-up. Right? Now, this is just like what happened before, but check out what happens when I go to decompile code. Now it's showing me the decompiled class of the method that I intercepted. So now, obviously I'm not going to be able to locate it right now, but you can browse through this, find your function, and you'll see the code that's in that function. So now you'll be able to analyze, in what way would you be, your changes would affect the code path. So it'd still be useful to have the other IDE, right? But for having that quick visibility into the code that you're actually going to mess with right now I found to be really helpful. So we'll probably say that's enough with the demo. We have lots of videos and screenshots online and stuff for just getting started with JavaSnoop, or whether or not you want to figure out how to attach to processes, and doing canary mode, and we're gonna have a bunch of videos out there. We already have some out there right now, and screenshots that break down the UI to hopefully help you out. We have a frequently asked questions. Hopefully we did everything that you would want. If you guys have any requests, I love working on this thing, so it'll probably be in the next feature if it's something cool. I have one last slide, I think. Is this from current slide? Good. Okay. Okay. So there's a bunch of people that help me out with this. Not only feedback, code, and UI help, and all this kind of stuff. This is not a one-man project. All kinds of people. GDS helped beta test it. Yeah. So lots of people helped, and thank you to all the people who helped. And here's the URL to get it. Like I said, available today. YouTube videos and stuff all online. And if you have any questions, I guess now would be a good time to ask them. Question?
So with, I wrote a very similar code using JVM and C code, and I didn't have any problems with the security settings.
Probably because you're executing natively.
Yeah, I was wondering if that would be support the, at least enable some safety for you.
Yeah. The 1.6 attach API was just so much easier than the JVM TI. That's the reason I went. I'd love to talk to you about your tool, though, afterwards. Question? Yes. You can just, there's another menu option that just says decompile a class, and you can just type a class in there, and or you can pick a class through the UI and just dump any class file. Question? Okay, there are lots of questions. right here up front first.
Have you tried this?
That's really rude.
Do you have any intuition about how useful it would be with like obfuscated?
Yes, I have terrible news. JavaSnoop totally won't help you with understanding obfuscated code because you're looking through the methods and they're like, the methods are named A, B, C, D, E, F, G, and the classes are all named something similar. And yeah, so the obfuscation makes the code unreadable. So JavaSnoop can't help you read it any more clearly than that. There's deobfuscators out there, but yeah, canary mode works. So you don't necessarily need to know, the method, stuff about the method to see it go through there, right? So canary mode can't help with that, but in general, browsing through the code still doesn't help too much with obfuscation on. There's another question back there? Yeah, so I have attached to Tomcat, and so the question was, have you thought about plugging this into J2E? Any J2E?
Me.
What's that?
Me.
Oh, J2ME.
Yeah.
Oh, so yes and no. So for like the Android JDK has an instrumentation API, but it's different. J2ME, I don't know if it's going to work there, but I know there's instrumentation options for J2ME level applications, but I don't think this will work out of the box. But if you can run it in an emulator in your desktop or on your laptop, then it would probably be fine because it's using your J2SE that's right there.
So what about the server side? You get a big component server. Would it work there?
Sure. Yeah. Like I said, I've attached to Tomcat, and all that complexity with all the different class loaders going on. It makes things hairy, but JavaSnoop kind of just comes in at the end, and all that stuff's easy now because I see all the classes from all the different class loaders, so you can. It's really helpful in debugging actually. So.
What about canary mode for large codebases?
Yes, let's talk about that. So it'll be slower. So just the eyeball test, I would guess it makes things 15, 20%, maybe 30% slower. Yeah, but it's slow. I mean, I don't like it to be that slow. Question?
I got a feature request. You know how in IDA you can add comments in line to be disassembled?
Okay.
Can you do that with your JAD output?
Like put some metadata into the output?
Yeah, so like you have obfuscated code, and you know like some certain class like maps to this. You just add a note to it for like further reference.
Absolutely. Somebody else had a question back there? No? Question? Yes. Yes. So we build a linear graph just straight down. The only problem is if there's two threads, or if there's multiple threads, this will never happen. But if there's multiple threads operating on that data, you'll get the chirps back in whatever order the threads are executing, so it may end up out of order. But it's probably going to be one thread, and it's going to come down in a linear order. So, we can't build like a. Well, I mean, the data flow is only going to be it's going to be one straight vortex, right? Whatever. So it's not going to be a real big graph, but it'll be a graph. Somebody have one here? No. Great, we've whittled the room down to like 12 people. Okay, guess that's it.